In this video, we want to look at what can go wrong in hypothesis testing. And in short, we are trying to examine the kind of mistakes, unintended errors that could go wrong in the setup of hypothesis testing in the practical scenario. In particular, we're going to identify two types of statistical errors associated with hypothesis testing, namely type 1 error and type 2 errors. These are otherwise called decision errors. So, you see, when you perform a hypothesis test, there are four possible outcomes, which we typically like two of them, and we don't like the other two of them because they result in errors. Take, for instance, if the null hypothesis is actually true, if it is really true, what possible course of action would we like? Would we like to reject it when it is true? Or would we not like to reject it? I would go with the option that if the null hypothesis is true, I do not want to reject it. So this is an instance of a correct decision. What is another instance of a correct decision here? Well, let's consider. If the null hypothesis is false, I am not interested in what is false. So if I'm not interested, I would like to reject it when it is false. So that would be another instance of a correct decision. The null hypothesis, if it's actually false, I would like to take the right decision to what? To reject it. That leaves two spots for type 1 and type 2 errors, where something can actually go wrong, or where we have decision errors. Take, for instance, if the null hypothesis is actually true and I were to unintentionally reject what is true, then I have type 1 error. Otherwise, if the null hypothesis is actually false, and rather than rejecting it, I do not reject it, then I have type 2 error. Now, you see, based on this, the possibility that I can have type 1 error, if we were to quantify it, that quantification or that probability of making type 1 error is what we have been calling a level of significance of the hypothesis test. So if I set my alpha to be 0.05, it means there's a 5% chance that I admit to myself as a researcher that I could be making what? A type 1 error, rejecting the null hypothesis when in fact it is true, just because that is what my sample data evidence presented me with. And that could be traced that sometimes back to the sampling process. If you use a convenient sample, it could be biased and could ultimately lead to a type 1 error or type 2 error. Whereas on the other hand, beta will represent the probability of type 2 error. You see, we would ideally like to make what? Type 1 error, the probability of making type 1 error, really low. So if the consequences of making a type 1 error are severe, what would you choose? What level of significance would you choose in conducting your test? Would it be 1%, 5%, or 10%? Well, if I know that the consequences of making type 1 error is very severe, then I would like to to limit the chances or the probability of making type 1 error. So I would rightly choose the lowest one. I'll try to minimize type 1 error by choosing my alpha to be the smallest of these options that I have been provided with. That will be 0.01. So it is responsible and smart to choose a level of significance that is extremely lower in order to what? To minimize, especially in the face of high cost associated with making type 1 error. By extension, this means that we are demanding strong evidence from the sample data before the sample data can cause us to reject the null hypothesis in favor of the alternative hypothesis. Now, let's consider a scenario. Testing for fibromyalgia. A patient named Diana was diagnosed with fibro-M, a long-term syndrome of body pain, and was prescribed antidepressants. Being the skeptic that she is, Diana didn't initially believe that the antidepressants would help her symptoms. However, after a couple of months of being on the medication, she decides that the antidepressants are working because she feels like her symptoms are in fact getting better. Question A. Write the hypothesis in words for Diana's skeptical position when she started taking the antidepressants. Well, how do we set up the null hypothesis? The null hypothesis is always a hypothesis of no difference. So, aligning with that definition, we'll state the null hypothesis as saying that antidepressants do not make any difference in the level of fibromyalgia symptoms. So, the alternative then would be that antidepressants can in fact affect the level of fibromyalgia symptoms, either in the negative direction or in the positive direction. In other words, they can help or possibly worsen the level of fibromyalgia symptoms. Question B. Explain what it would mean to make a type 1 error. To make a type 1 error here would mean to reject the null hypothesis when in fact or in reality the null hypothesis is true. What is a null hypothesis? The null hypothesis says that antidepressants do not make any difference. So if we were to reject this and go in favor of the alternative and conclude on the alternative, when in fact the null hypothesis is true, then in this context, making a type 1 error involves concluding on the alternative hypothesis that antidepressants can worsen, can help or worsen the level of fibro-M symptoms when in fact they make no difference. They make no difference. All right. What would it mean to make type 2 error in this scenario? In general, the type 2 error arises when you fail to reject the null hypothesis when in reality the null hypothesis is false. So that means if we fail to reject the null hypothesis, when in fact it is false, it means we're going to conclude on the null hypothesis when we really should not be doing that. Okay, so that means that in this context, we will conclude that antidepressants do not make any difference in the level of fibromyalgia symptoms when in fact they actually do. That would be what would be the description of type 2 error in this scenario.